Welcome to the AWS Certified Cloud Practitioner Prepcast, where we guide you through everything you need to know for your certification exam. Whether you're just starting or looking to refine your knowledge, this course will set you up for success. Brought to you by baremetalcyber.com. Let's get started. Conversational interfaces are no longer niche. They are central to how customers expect to interact with businesses. From chatbots on retail sites to voice-driven help in call centers, the ability to understand natural language and respond in context has become a baseline expectation. Amazon Lex provides AWS customers with a managed conversational AI service that makes these experiences possible without requiring teams to build natural language processing models from scratch. Lex allows developers to define structured conversational flows, what users might say, what information needs to be collected, and how the system should respond, while AWS handles the complex task of interpreting human input. This shifts the effort from building deep learning pipelines to designing business logic and customer experience. At its foundation, Lex revolves around intents, which are the goals users are trying to achieve. For instance, if someone types, "I need to reset my password," the intent might be reset password. Each intent is supported by utterances, the different ways people might phrase that request. A single intent could have dozens of sample utterances, like "forgot password," "can't log in," or "help me recover my account." Lex uses machine learning models under the hood to match real-world phrasing to these intents. By capturing the intent correctly, the bot can direct the conversation toward gathering the right information and fulfilling the request. To complete an intent, Lex often requires slots, which represent pieces of information needed to carry out the request. Consider a flight booking chatbot. The user intent might be book flight, but completing it requires several slots: departure city, destination, date, and number of travelers. Lex prompts the user to fill missing slots using slot elicitation prompts such as, "Where are you flying from?" or "What date would you like to travel?" This makes the conversation interactive and ensures that structured data is collected in a natural way. Without slots, conversations remain vague. With slots, they become actionable workflows that map directly to back-end processes. Lex offers a library of built-in slot types for common data like numbers, dates, and locations, reducing the burden on developers. But it also supports custom slot types, which allow organizations to model business-specific values. For example, a bank might define a slot type for account categories checking, savings, or mortgage, or an online store might define a slot type for product families. Slot validation rules ensure users provide acceptable input. If someone says they want to book a flight to Mars, Lex can reject the value and prompt again. This combination of built-in intelligence and domain customization makes Lex adaptable across industries. Conversations often require more than single-turn exchanges, and Lex provides dialogue management and confirmations to handle these longer flows. For instance, once all slots are collected for a password reset, Lex might ask, "I'll reset the password for your account ending in 1234. Is that correct?" This confirmation step prevents errors and gives users confidence that the system understood their request. Developers can choose between letting Lex manage these dialogues automatically or writing custom logic for more control. This balance allows simple use cases to be handled with minimal coding while still giving enterprises room for nuanced experiences. Maintaining conversational flow across multiple interactions requires session state, managed by Lex through contexts and attributes. Contexts allow the bot to remember what stage the user is in, such as being mid-booking or awaiting confirmation. Attributes pass metadata between turns or even across intents. For example, if a user says, "Book me a flight to Chicago," and then follows with "make it tomorrow morning," the context ensures that the bot understands the user is still referring to the same booking. Without this, every turn would be treated as a new, disconnected request, breaking the illusion of natural conversation. Completing an intent often involves triggering real systems, and Lex integrates with AWS Lambda for fulfillment. Once all required slots are gathered, Lex can call a Lambda function that interacts with a database, queries an API, or executes business logic. For example, an order tracking bot could gather an order number slot and then invoke Lambda to check status in DynamoDB or an ERP system. This design pattern makes LexBots not just conversational shells but true front ends to enterprise workflows, turning natural language into actionable system events. Global applications require broad linguistic support, and Lex accommodates this with multi-turn, multi-locale, and multi-language bots. Multi-turn dialogues allow complex workflows where information is collected over several exchanges. Multi-locale bots let organizations deploy the same logic across different countries, adapting prompts to regional phrasing. Multi-language support ensures that a user in Spanish or German can interact with the same system as an English speaker, widening reach without requiring multiple distinct bots. This versatility is crucial for multinational enterprises or consumer-facing apps with diverse audiences. LexBots are not confined to a single interaction channel. They can be embedded into multiple channels such as Amazon Connect for voice IVRs, web chat widgets, SMS text services, and popular chat applications like Slack or Facebook Messenger. This flexibility means a single LexBot can serve as the conversational core across many user touchpoints. A customer might ask a question via SMS, interact with the same bot on the company's website, or call into a Connect-powered contact center, all handled by the same backend logic. This omni-channel integration ensures consistency and maximizes ROI from each bot. Input and output in Lex support both text and audio, with streaming options for near real-time responsiveness. A user can type into a chat window or speak into a microphone, and Lex can handle both inputs seamlessly. Likewise, Lex can output text for a chat interface or audio for a voice channel, often paired with Amazon Polly for natural speech synthesis. This multimodal flexibility makes Lex equally useful for building chatbots, IVRs, smart assistants, or accessibility tools where voice is essential. Streaming APIs further enhance responsiveness, ensuring that voice interactions feel natural rather than delayed. For operations and governance, Lex supports conversation logs, which can be stored in S3 for long-term analysis or streamed to CloudWatch for real-time monitoring. These logs capture user utterances, matched intents, slot values, and bot responses, creating a rich dataset for improvement. Analytics teams can mine these logs to identify where users abandon conversations, which utterances are frequently misunderstood, or which intents dominate usage. This feedback loop ensures that bots improve continuously, evolving from simple prototypes into robust conversational systems aligned with real-world user behavior. Bot development is iterative, and Lex supports this with versioning and aliases. Developers can create stable versions of bots, intents, or slot definitions while experimenting with new updates. Aliases such as prod or test allow traffic to be routed to the appropriate version without disrupting live users. This separation enables safe updates, controlled rollouts, and rollback strategies if problems arise. It mirrors software development practices like staging and production environments, embedding lifecycle discipline into conversational AI development. No conversational system is perfect, so Lex provides mechanisms for error handling. Fallback intents capture utterances that don't map to any defined intent, while clarification prompts handle ambiguous responses. Instead of leaving the user stranded, the bot might say, "I didn't catch that, could you try again?" or offer guidance on supported actions. These safeguards make the bot more resilient, handling the messiness of human input gracefully rather than rigidly. Designing effective fallbacks and clarifications is a key part of user experience design in Lex. To evaluate effectiveness, Lex includes analytics dashboards that track intent success rates, slot completion, and conversation abandonment. High abandonment may indicate confusing prompts, while low success rates may signal missing utterances or overly strict validation. By monitoring these metrics, teams can refine both dialogue and business logic, creating iterative improvements. Analytics shift bot building from guesswork to evidence-driven design, ensuring that conversational experiences meet user needs and business goals. Security and privacy are built into Lex's design. IAM roles and permissions govern who can configure or invoke bots. Conversation logs stored in S3 can be encrypted with KMS, ensuring compliance with data protection requirements. Privacy controls allow sensitive fields, such as credit card numbers or medical information, to be masked or excluded from logs. These controls make Lex suitable for industries like healthcare, finance, and government, where conversational AI must operate under strict governance. By embedding security and privacy at its core, Lex supports enterprise adoption without compromising trust. For exam purposes, Lex is strongly associated with keywords such as intents, slots, utterances, slot elicitation, and multi-turn conversations. If a question describes workflows where a bot collects structured inputs through natural conversation, such as booking, ordering, or troubleshooting, Lex is the correct service. Unlike SageMaker, Lex does not require custom model training. It is a managed AI service that provides conversational intelligence out of the box, ready to integrate with Lambda, Connect, and other AWS services. If Lex handles the conversational logic, Amazon Polly provides the voice. Polly is AWS's fully managed text-to-speech (TTS) service, converting written text into natural-sounding speech in dozens of voices and languages. This capability enables applications to speak to users, whether in customer support systems, e-learning platforms, or assistive technologies. Instead of robotic or monotone speech synthesis, Polly's voices are modeled on real human speech, making digital interactions more engaging and accessible. By pairing Polly with Lex, developers can create full voice-based assistants that understand user intent and respond naturally in real time. One of Polly's most important advancements is Neural Text-to-Speech, NTTS, which uses deep learning to generate lifelike voices. NTTS voices capture the subtleties of human prosody intonation, rhythm, and stress patterns that traditional concatenative synthesis struggles to reproduce. While Polly still offers standard voices at lower cost, NTTS is the preferred choice when quality is paramount, such as in customer service or consumer-facing applications. The result is output that feels closer to human speech, reducing listener fatigue and improving user experience. Organizations can choose voice types depending on budget, use case, and audience expectations. Polly also supports SSML speech synthesis markup language, which gives developers granular control over how text is spoken. Through SSML tags, developers can insert pauses, less than break greater than, adjust emphasis, change pitch and speed, or even define phonetic pronunciations. For instance, acronyms like EC2 can be spoken correctly with phoneme markup, and complex names can be pronounced with lexicons. SSML allows tuning for context-slowing speech for educational content, adding emphasis in marketing scripts, or introducing pauses for dramatic effect. Without SSML, output may sound flat. With it, speech becomes expressive and tailored. In addition to SSML, Polly offers custom lexicons for pronunciation management. Lexicons allow developers to define how specific words should be spoken, which is particularly useful for domain-specific terminology, brand names, or uncommon words. For example, a healthcare application can ensure medical terms are pronounced correctly, while a retail bot can handle brand names that define normal linguistic rules. Lexicons ensure that Polly adapts to the unique vocabulary of each industry or organization, creating a more professional and accurate user experience. Polly offers both real-time streaming and batch synthesis modes. Real-time streaming provides immediate playback, making it suitable for conversational applications like IVRs or chatbots. Batch synthesis allows large volumes of text to be converted into audio files stored in S3, which is useful for e-learning modules, podcasts, or audio-enabled articles. By supporting both workflows, Poly meets diverse needs: responsive interaction for dialogue systems and high-throughput generation for media production. Organizations can combine these modes depending on whether the focus is interactivity or content creation. A unique feature of Poly is its ability to generate speech marks, metadata that indicates word, and VisMe, mouth shape, boundaries. These speech marks make it possible to synchronize audio with visual elements, such as animated avatars or subtitles. For example, a virtual assistant could lip-sync its mouth movements with Poly's generated speech, or video subtitles could be perfectly aligned to spoken words. Speech marks expand Poly beyond simple audio generation into richer multimedia experiences, supporting accessibility, animation, and immersive applications. Poly provides dozens of voices and languages, with multiple styles where supported. Developers can choose a formal voice for professional contexts, a conversational style for customer support, or a more expressive voice for entertainment. Selecting the right style and tone is crucial for aligning speech with brand identity and user expectations. In multilingual applications, Poly supports localization by switching languages or voices dynamically, enabling the same application to serve global audiences without maintaining separate systems. This breadth of voices and languages reinforces Poly's role as a versatile platform. Audio output from Poly can be tailored to different contexts with multiple formats and sample rates. Applications may need MP3 for web delivery, OGG for streaming, or PCM for telephony systems. Sample rates can be chosen to balance quality against bandwidth, higher rates for high-fidelity playback, lower rates for constrained environments like phone lines. This flexibility ensures Poly's audio integrates smoothly into diverse environments, from low-bandwidth IVRs to high-quality e-learning courses. Developers can generate exactly the right format for their use case without extra conversion steps. Poly-generated audio can also be cached and reused, a crucial feature for cost control. Because billing is based on the number of characters processed, frequently generating the same audio can be expensive. Instead, teams often synthesize static prompts once, store them in S3, and reuse them across applications. Dynamic text, such as personalized updates, can still be generated in real time, but reusable assets like greetings or common instructions are best cached. This caching strategy balances responsiveness with efficiency, ensuring predictable costs without sacrificing user experience. Integration is one of Poly's strengths. In Amazon Connect, Poly provides dynamic voice prompts for IVR systems, enabling natural-sounding interactions for customers calling into a contact center. In mobile or web applications, Poly can convert dynamic content into speech, making apps more accessible. E-learning platforms can use Poly to narrate educational material, scaling content delivery without relying on voice actors. These integrations illustrate Poly's versatility. It is not a standalone tool, but a building block that enriches existing AWS and third-party systems with voice capability. Security remains a core consideration for Poly usage. IAM policies define which applications or users can generate speech, ensuring least privilege access. Audio files stored in S3 can be encrypted with KMS, ensuring sensitive speech outputs, such as healthcare or financial data, remain protected. Applications embedding Poly must ensure that outputs are managed securely, especially if generated audio contains personal or regulated content. By aligning with AWS's broader security ecosystem, Poly ensures that adding voice to applications does not compromise compliance or privacy. Cost awareness is critical for scaling Poly's solutions. Pricing is based on the number of characters processed, so verbose prompts or unoptimized text can increase bills unexpectedly. Strategies like caching static prompts, consolidating requests, and reusing stored audio help minimize costs. Choosing between standard and neural voices also affects expenses. NTTS delivers superior quality but at a higher rate. Teams must weigh user experience against budget constraints, using Poly's flexibility to strike the right balance between fidelity and affordability. Localization workflows benefit from Poly's multi-language pipelines. Applications can dynamically select languages and voices based on user settings, ensuring content feels local. For example, an international news service might deliver audio articles in the reader's preferred language automatically. Combined with Lex's multi-locale support, Poly enables bots and apps to speak naturally across global markets, extending reach and inclusivity. Localization goes beyond translation. It requires culturally appropriate delivery, and Poly's voice options allow developers to tailor tone and pacing to audience expectations. Despite its strengths, Poly is sometimes underused when applications fail to leverage its expressive features. A common pitfall is flat, robotic delivery when developers simply feed raw text without SSML or lexicon tuning. This undercuts user experience and makes interactions feel outdated. By adding pauses, adjusting emphasis, and refining pronunciations, teams can make Poly outputs sound far more natural. Another pitfall is neglecting caching, which leads to unnecessary costs. Awareness of these pitfalls ensures Poly implementations remain both effective and efficient. For exam preparation, Poly is often cued by references to text-to-speech, voice generation, or audio synthesis. If a question describes converting content into spoken audio, Poly is the correct service. If the scenario involves conversational intent recognition or chatbots, Lex is the service in play. When combined, Lex and Poly form the foundation for voice-enabled conversational systems, such as interactive IVRs or accessibility tools. Together, they cover the full experience. Lex understands what users mean, and Poly responds in human-like speech. That concludes today's episode of the AWS Certified Cloud Practitioner Prepcast. Be sure to tune in for the next episode and visit us online at baremetalcyber.com or cyberauthor.me for more resources, including news, mailing lists, YouTube videos, podcasts, and much more.